B here, just wanted to quickly go through cosecant, secant, and cotangent. I know the sine graph was long, and I'll probably make a decently long cosine graph for the transformations, but I just want to quickly talk about cosecant, secant, and cotangent, which are the reciprocals of sine, cosine, and tangent respectively. As you notice, like our basic sine curve, which we reviewed in the video if you watched it, or if you're already good at it from class, then you know that they are the reciprocals. So cosecant is the reciprocal of sine, which means those values that we graphed will be essentially opposite, right? So if I'm talking about cosecant, which is 1 over sine, I could still use my quadrants and my unit circle to help me develop the graphs. But like tangent, which has some undefined values, we have to consider that you will have some undefined values with cosecant and secant, because there are times when sine and cosine are 0. So if you have 1 divided by 0, you're going to have undefined, which is why you notice that cosecant and secant, and of course cotangent and tangent have these dotted lines. And remember, those dotted lines are asymptotes. And the reason we get asymptotes is for undefined, division by 0. So the only kind of important thing to mention about cosecant, secant, and cotangent is that they have asymptotes. Also, like tangent, they have undefined amplitude, because remember, amplitude represents the distance from the midline to the maximum of the graph, or the distance from the midline to the minimum. And since tangent, cosecant, secant, and cotangent don't have maximum values, there's not going to be an applicable amplitude. Okay, for the most part, if you were asked a question about cosecant, secant, and cotangent, you would just go ahead and use the graph, or use what you know about graphing sine, and then graph the reciprocal, cosine, and the reciprocal, and so forth. With the Inspire, you have all of your trig functions listed. And so if I wanted to graph cosecant, I would just type in cosecant and then x, and then it would graph the cosecant of x. Now notice my my calculator's in radian mode, but I'm going from 0 to 10, and I'd rather go to from 0 to 6.28, which is 2 pi. So again, you can always go to the menu and then zoom, and we'll zoom trig so that we get a more accurate picture. Now you could analyze the graph or trace the graph to see where those undefineds are. So when x is 0, it's undefined. Notice it popped up automatically. We could also type in one of those values if we wanted to see where else is undefined. So if we go back to that note page, we can see on the note page for cosecant, it's undefined also at pi, right? Because that's the next position where sine is 0. So we could type in the trace menu just pi, and it should also show up x equals pi. It'll show up as 3.14, approximately pi, and then undefined. So you can test them in there, and you can do the same process for secant and tangent and cotangent. For those of you that are checking or trying this at home and you have an 84, you have to remember the rules for the reciprocals. So you will have to type in 1 divided by sine x in order for it to graph cosecant, and 1 divided by cosine x in order for it to graph secant, 1 divided by tangent x in order for it to graph cotangent. Okay, so that's pretty much all I wanted to mention related to cosecant, secant, and cotangent. Notice the period of cosecant and secant is consistent with the periods for sine and cosine, just like tangent and cotangent have consistent or the same periods. All right, I'll see y'all on next class.